Today we're going to look at some of the best robots the FTC DECODE season has to offer, and using that full 18 inches for that height. And you'll see why in a moment here. We're going to look through some interesting ways you can design intakes, some better ways that teams have been improving their bases, particularly some lifting style bases, some really efficient shooting methods you might want to try. And then we'll take a look and analyze some world record matches with autonomous patterns, and then some also match play. So first up, we've got a sorting intake from team 21229. They have a really interesting looking intake bar and their automatic sorting method as well. So if you look, they've got a boot kicker here. So if you look up top here, they've got a little boot kicker that's actually spinning left and right on a servo, it looks like, to be able to move the ball as it comes in. And it looks like they've got a color sensor just in the bottom right there, and that is reading the color of the ball as it comes in to be able to change the direction of this. Actually, correct myself, it looks like it's actually on a continuous rotational servo that's just changing the direction that it's moving as it comes in. And they've also got a few boot kickers up here as well that are then funneling into respective sides. I think that's a really interesting way of getting around the indexing problem and having wider channels on their robot as well. Last thing on the intake that I like having a little bit of compliance up on the edges here so that the whole thing can lift up and down. Looks like they've got a little simple 2-bar linkage that's helping maintain that thing in the position that they need. And I found this being pretty effective at being able to pick things up and down. So good job on that, team 21229. Next up, we've got a world record solo autonomous here from Cube Robot. And I want you to take a look at how it decides to do its patterning. So it fires the first 3. Not only does it have really impressive throughput, but take a look at what it decides to do now. So now it goes ahead and open up the door, and as it's opening up that door or that gate, it is also waiting to collect the balls to be able to intake them in. So they sit there and wait at their gate to be able to intake another 3, and then fire it up again, and then continuously fire those same 3 before they finish it up, fire those 3 again, and then I think they go for even more on there, and then fire it up. Now, the very last point here where they're finishing, I'm not 100% sure if they got off the launch line here, just because it's hard to tell from this current design. It might be that their top right-hand corner is not in there. But in any case, seriously impressive work. And while it's not indexed, it does have full 9 balls shooting up there at the end as well. This also plays well with other teams in that it's capable of opening and closing that gate several times throughout that match, which means that if their partner were actually shooting things in during that auto, it would also significantly improve that. So that's some really good work on that. It looks like team 23641 CubeBot. You should be really impressed with that auto pathing. And it might be something your team might consider trying as things move on. Next up here, we've got team 21689. And they've just got some interesting, it's pretty impressive. They've got water jet manufacturing at their own facilities to be able to muck around these things with steel. But I think this is an interesting point for teams to look at by making their own steel flywheels, because it allows your ball or allows your flywheel to have a little bit more inertia. And because it has more inertia, it's less likely for it to need to spin back up to speed as time goes by. So you can have a much higher throughput. And teams that seem to have very high throughputs tend to have very heavy flywheels. These are easy things you can water jet out. You can plasma jet these out. I believe that GoBuilder and Swift also sell a few different steel flywheels. The key point here is you want the weight to be near the edge of the flywheel, not necessarily in the center of that flywheel. It also has to be very well balanced. So sending it out to some sort of local company in a place you have might be a really good way of adding in some extra inertia to your flywheel. Next up, we've got team Crossfire 9968. And I think they just have a really interesting looking shooter. The whole thing pivots up. They have bar that's able to rotate back and forth. It can only pick up 2 balls at a time, but the whole thing pivots up and down. So their flywheel acts as both a flywheel and as an intake. And I think that's a really creative solution for getting around this problem. Now, I wonder, because of how they're pivoting, if they're going to be able to have the space to be able to get 3 balls intaking in at once. And it looks like it would be pretty size constrained unless they had some sort of, say, J hook that they were able to curve around that pivot point as well. But it's a really creative solution by having both their intake and the shooter be the same wheel, especially when it is a much smaller intake. Looks like it's powered by a single motor for it to be able to get it up to speed. So nice job on that, team 9968. Next up, we've got team 22411 Wild Squirrels. I don't want to show this off just showing a sort of behind the scenes look or an under the cap look for teams. at how some teams are going around making their turrets. So I really like they've got this design opened up. It's quite simple. It's quite clear to be able to see they're driving with a DC motor, so you can get quite a quick rotation as time goes by. As well, it'll be harder to back drive this as well, so you hopefully will not get as much backlash with that double herringbone gear. And then it looks like they're just using a large 8-inch Lazy Susan gear. And I've seen a lot of teams use a Lazy Susan as a setup, and it's a quite efficient and quite quick way of getting a turret up and running. So this might be a good one to come back, take a look at if you're trying to design a similar shooter style. Last up here, we've got team 14906. I want to show this robot off because it's a non-turret for their hoods. The entire robot does have to rotate, but they are capable of moving and shooting while they're coming in. So watch this robot here. It's able of moving and shooting while the whole robot is rotating. And I think this is a really interesting way of setting up a little bit of PD control to allow the robot to be able to rotate the whole chassis around as time goes by. And if your robot is such a narrow robot like their team is, it's a great way of getting around that problem of how can you make sure that you're constantly lined up with the turret. The one thing that this might have more struggles with is if they come up and another team decides to play defense or they hit another robot, it's less likely for it to be able to auto-align itself in. In any case, this might be something to consider with your team as it is you're rotating and pivoting yourself towards that gate as you're still capable of driving around just by adding a little bit of offset to your drive controls. Next up, we're going to take a look and looking at some different bases here. So this is a match at the Riken Robo Bowl with 6,032, 3737, 2394, and 4410. I want you to take a look at this robot down here in the bottom right-hand corner as it starts to do its lift. Because I'm seeing a lot of teams come up with a lifting design, be lift up. And I think it's a really cool design. One thing you have to be really careful for is that base plate has to be very solid and your robot has to be well aligned. So I'm not quite sure what happened here, but as we can see, this robot's actually pitching up on a bit of an angle here. Not that excessive, but it is clearly pitching up on an angle, and it looks like the base plate itself is also not particularly wide. Base plate itself looks like it's probably about 7 inches across as it floats around, and as it comes up to lift, we start seeing that it comes over and tips, unfortunately. And I think this might be something that teams need to look at. I'm not sure if their encoders were tuned properly or if they didn't reset the robot back up to the front to make sure it's zeroed out. Having some sort of magnetic limit switch to make sure that these encoders are at the same heights when you start lifting, I think it's going to be really important for teams that try to do a lifting design. On the flip side here, we've got team 25538, and they've got a little bit of kick testing here they've been able to do, concerned that a robot might fall over. And looking at the size of this base plate, I think it's a really interesting way of setting up their base plate. It's clearly quite stable as another robot comes in to hit it. And while they're not giving, they actually do give a couple good kicks up there near the end as well. So having a rather wide base plate, I think is going to be really critical for these. It looks like they're just using some standard Masumi slides as well for that. Probably SAR 230s or maybe even 220s for that as we move around. Or those might even be Viper slides. It's hard to tell from in this current shot. But there's clearly no lacking a weight on this robot, and it's clearly pretty beneficial. So having a nice wide side plate will be pretty beneficial here too. Also want to show off a quick shout here to 10273. The cat in the hat is back, and it is somebody who's kind of taken a design that I suggested earlier in the season with a single offset robot slide, and then are moving that thing up and actually having a pretty successful lift. So pretty cool stuff from that, just to see that kind of out in the wild and functioning around. Now, last up here, I want to take a look at a couple matches. We've got the DECODE Hawaii Championship here, and I want you to take a look at the robot specifically I want you to focus on down here is this robot in the bottom that is 6962. I think it's got a really strong cycling strategy, and their driver's clearly got a lot of practice to be able to pull themselves in to be able to fire. And then this also might be something to think about here with Team Blue. With your driver and your practicing, it's really important to practice driving with other teams. because as Team Blue is firing around, they're mostly thinking about what it is that I'm going to be doing on the field, as opposed to also trying to think, what are other robots doing in the field? Because several times throughout this match, you've got Team 69-62 capable of coming inside the blue human zone to be able to pick up these balls and pick up those artifacts rather freely without having to be worried or concerned about the other team coming in and getting in their way. So it's something to think about as your blue team, looking at maybe your drive coach in the back is also taking a look at what the other team is currently focusing on as it is as the whole field's moving around. So you can say, okay, I'd like you to focus a little more on this section because this robot is pretty capable of just cleaning up and picking up quite a few artifacts as time goes by. So something to think about for your drive coaches. And last up here, we've got the Michigan State Championship for playoff number 7. And take a look at what happens to the Blue Alliance in this match, particularly what happens to team, I believe this is 10-104. Yeah, it's 10-104. So 10-255 ended up being the winning alliance captain here. I believe the Fun Robotics Network has a fantastic Behind the Bot episode on taking a look at how their robot sets up. You should definitely go take a look at. But I want you to take a look at 10-104 at the end of their period and how they actually start to transition in, because they start firing in quite a bit. So looking at 10-104, they are capable of starting to fire right from the start, but at a certain point throughout the match, I believe they had a chain that was running one of their main systems and that broke, and then they're no longer able to actually lift it up. So take a look at how they do a bit of defense transition here. I don't believe that they're capable of shooting anymore. Driver recognizes it pretty quickly and then moves straight into defense to try to hold on, because right now you've got 117 points to 140. You've got a minute left. And you can probably think what's going through 10-104's mind as they're driving around. They've just lost their main scoring mechanism and a good chance that they might not be able to advance past this playoff. So now it's time to stop some of these red robots from being able to come in while still focusing on their own gate as well. So I think this is a really strong play. So we actually see that the blue driver is starting to use their own lights against the other drivers so they can see when they're capable of firing in, when they're capable of not. And then up here in the next section, take a look at when they come down in this bottom left-hand corner in that far launching zone. I really like these tall polycarbonate sheets that they have on that robot and using that full 18 inches for that height. And you'll see why in a moment here. Because a lot of these shooters are not firing at an arc that gets them above 18 inches. So as they come up here to be able to fire, I believe this is the next section as red comes along. They give a little more bullying to this robot in the top right-hand corner. And then as this robot tries to fire in here, they're capable of actually blocking those shots and deflecting them off of the top of their large polycarbonate shields. And using that height advantage to your advantage is going to be a big one here, because that's a great defensive play that I haven't seen a lot of robots do up to this point. And it does really add a lot of benefit in. And of course, they've got a little kickstand here that makes it easier for 2 robots to get fully within their base at that section. And because of that good defense, as well as the exceptional performance by 10-255, and getting some really high throughput there, it allowed them to hold on to their lead as well. So some very impressive work, some very quick thinking from 10-104 on that as well. If you've got a robot mechanism piece that you want to consider other people be able to see on a future FTC Fridays, let me know in the description down below. There's a form you can fill out, as well as if there's matches you'd like me to analyze as well for some different plays. And as always, best of luck out there this FTC season.